Okay, team challenge number 11 was about the quaternary structure, and I used the protein Rubisco, which is of course the most important protein on the planet. You're given in the question that Rubisco has two subunits, a large subunit L and a small subunit S. And the large subunit is 470 amino acids long, and the small subunit S is 113 amino acids long, and this happens to be for Prochlorococcus. So, the first question says, given the oligomeric structure, which means its quaternary structure, is L8S8. There are 8 large subunits and 8 small subunits put together. What's the molecular weight of native Rubisco if the average amino acid in a protein is 110 grams per mole? So basically we have to figure out what the average molecular weight of the two different subunits is by multiplying. This is 470 amino acids, and this is what this is. Okay? Amino acids and grams per mole of amino acid in a protein. So what we end up with is the large subunit having a molecular weight of 51,700 grams per mole, and the small subunit having a molecular weight of 12,430 grams per mole. Knowing the stoichiometry of the oligomer, I take the 51,700 grams per mole times 8 plus the molecular weight of the small subunit times 8 to get the overall molecular weight, which is 513,040 grams per mole. That's big. Okay? So that's the first part of the question. The second part of the question asks you how many of these hexadecamers, there's a good word, hexadecamer meaning 16 mers, are there in a Prochlorococcus cell, given a few things. Okay, the diameter of a Prochlorococcus cell is 0.6 micrometers, and bacterial cells have a concentration of protein of 250 milligrams per mil. These are pretty rough numbers, but we can work with them. And we know that Rubisco, the enzyme we're talking about, is about 5% of the total protein in the cell by weight. So, we have to figure out a few things here. First of all, let's figure out what the volume of the cell is. The volume of the cell is 4/3 pi r cubed. R here is 0.3 microns. That works out to 0.113 micrometers cubed, okay, which is equal to 1.13 times 10 to the minus 13, I think that's supposed to be 19, meters cubed. And there are 1,000 liters in a meter cubed, so that this is 1.13 times 10 to the minus 16 liters. That's the volume of a Prochlorococcus cell. Okay, now let's figure out how much protein is there. There is 250 milligrams per mil, which I can convert to 250 grams per liter. Okay. Times the volume of the cell, 1.13 times 10 to the minus 16 liters, I end up with 2.83 times 10 to the minus 14 grams per cell. Okay? This is because this is liters per cell here, the volume of one cell. So I end up with 2.83 times 10 to the minus 14 grams of protein per cell. Now I use this piece of information that Rubisco is about 5% of the total, and I end up with a new weight of 1.41 times 10 to the minus 15 grams of Rubisco. Okay, that's good. I can divide that by my molecular weight of Rubisco, 513,040 grams per mole, and I will get the number of moles of Rubisco in a cell, which is 2.76, I'm going this way now, 2.76 times 10 to the minus 21 moles But I want to know how many complexes, so I've got to multiply this by Avogadro's number, which comes out and gives me a value of 1,659 Rubisco molecules, complexes, per prochlorococcus cell. And that's the end of that.